The man behind the scenes was John Stuart Bell, an Irish physicist. Bell's theorem states, no physical theory of local hidden variables can ever reproduce all of the predictions of quantum mechanics. This ties back with the uncertainty principle. If the momentum of a particle is known, then its position is unknown, and vice versa. One of the most famous proponents of hidden variables was Albert Einstein. The hidden variables concept is a thought that there is a deterministic factor which can be calculated to predict the outcomes of the results shown by quantum entanglement. This quantum entanglement idea is that a pair like an electron and positron are entangled or connected with each other no matter the distance between them. These theories try to characterize why the two parts of a particle behave opposite to one another. The underlying idea here is that there is an instantaneous communication, a speed faster than light. Herein lies the bulk of the mystery behind the behavior of a pair of particles. For example, if one of the pairs, like the electron, results in a spin-up state, then the positron will always be in a spin-down state. Now there are many thought experiments to overcome this, like making two simultaneous detections. But such an experiment would mean absolute determinism, that there is no free will, an idea uncomfortable with many. Though it was Bell who proposed a simple statement, an inequality equation comparing probability of outcomes. He did this to disprove Einstein by finding an error in his hidden variables theory. If Einstein was right, then the inequality equation of probabilities would hold true. But as it has been found out, the inequality is false. Bell put his theory to the test. He first conducted his experiment with poor equipment, some of which were reused from previous experiments, or even stolen. However, many complained about inaccurate devices employed, leaving the experimental results unconfirmed at best. Bell's opponents made a valid point. The laser optics experiment needed precise light detectors to avoid any unaccounted for errors. Yet this left intrigue in other physicists like John Clauser and Alan Aspect. But it was Alan Aspect who 10 years after Bell first tested his theorem, used much more advanced equipment to repeat the experiment. The laser experiment roughly worked like this. A crystal divides laser light into two photon beams. The photon pairs are then passed through a set of detectors which determines the polarization. The high photon count yields a more accurate reading. Bell's inequality comes into play here, which states that the sum of four probability tests with different settings should add up to or less than equal to 2. The complicated laser particle experiment can be compared to a card game. The goal is to predict the color of pairs, either black or red, where the pair of cards represents an electron and positron. A red card will be a positron and a black card an electron. Since we know from quantum mechanics, if a card is black, then the next will be red. From this, one can assume that for a set number of games, the outcome should be 50-50. If one wins as many as they lose, then Einstein was right. And if not, then there is no clear explanation except that somehow the pair is in communication with each other. Now this leaves a lot of curiosity or questions on what exactly is reality and how it can best be defined. I know there are a lot of ideas out there, like we might be machines and we might have the similar characteristics and whatnot. However, there's so much yet to be explored, to be discovered, and to be found out that it is best to leave it to the imagination and to continue searching, to try to come up with a better explanation on how the universe really works.